I've been spearheading biogas projects in the US, Canada, and overseas for over 20 years. In that time, I've learned that it's critical to monetize the environmental benefits, avoided emissions especially, of anaerobic digestion from waste. I'm Alex McFarland, and this is the first of several analyses that review the connection between biomethane as a fuel and anaerobic digestion, or AD, as a powerful means of recycling organics while mitigating the climate crisis. I had prepared this work to coincide with the ratification of the International Maritime Organization's Net Zero framework, but thanks to meddling of the US and other fossil countries, the NZF vote is delayed a year. At least it's still alive though, and now we have a chance to perhaps strengthen or clarify NZF. One of the criticisms is that it would add more demand to already stressed biofuel supplies and would therefore end up relying on as yet unskilled e-fuels. Could carbon-negative biomethane be part of the solution here? Well, every year humanity leaves behind gigatons of decaying biowaste, crop residue, and manure that emit super-polluting greenhouse gases. What if new net zero regulations pulled that stuff into organics recycling AD plants that also gave us enough renewable fuel to decarbonize shipping, trucking, or other hard-to-abate sectors? Instead of wafting off into the atmosphere, that methane would be carbon-negative fuel conveying goods around the world. And biofuels competing with food, feed, or forests would be non-issue when we use waste feedstocks. With today's technology and mostly existing infrastructure, we're already fueling ships with liquefied renewable gas and biomethanol fuel. But is there enough organic residue out there, and what is it worth in emissions benefit? My analysis focuses on this question by connecting the world energy potential with the emissions reductions opportunity. So first, the International Energy Agency Biomethane Survey found there's enough sustainable biogas feedstocks to produce almost 1 trillion cubic meters of fossil gas equivalent energy. It's 3 times the energy needed to fuel the entire shipping industry and almost 1/4 of worldwide fossil gas used today, and it's largely rotting away. That's a lot of fossil gas that would not have to be burned, but the emissions avoided by recycling organic waste more than double the payoff and sum together to 9% of global greenhouse gases, which is an enormous opportunity. At $100 a ton carbon dioxide equivalent, that would be $400 billion every year. Now, it's important to note that my analysis is offering a gross total of methane and nitrous oxide emitted by the business as usual case. AD plants can in many instances eliminate these emissions, but they have their own impacts that reduce performance. Further, nitrous oxide reduction offered by AD depends on soils, climate, application methods, and so on. But an AD built and funded in significant part on its environmental benefits will transform unmanaged, minimally measured dumping, spreading, and burning into controlled and managed conversion processes. And this is a massive and necessary transformation here on Spaceship Earth. Also, IEA applied some capture estimates to each category of organics, and with the appropriate incentives and perhaps more feedstocks and fuel could be available. Finally, AD plants can form the heart of integrated biorefineries, where biogenic CO2 can be reused or sequestered, digestate can replace fossil fuel, synthesized fertilizers, or residual solids could be converted to biochar, all of which are proven add-ons to increase the potential emissions reductions. So the intent here is to illustrate the order of magnitude. Project factors will deduct or add to the total emissions benefits. But the bottom line is this: we need to dramatically expand biomethane production, with tens of thousands of new biogas plants around the world, each one being paid to generate renewable fuel and chew up waste diverted from the landfill, lagoon, or cropland where they currently decay or burn, mostly uncontrolled. But we must pull in the feedstocks under disposal of supply contracts where the waste generators may not be creditworthy and business as usual is cheap. So the energy and carbon payment coming from obligated buyers must be the reliable offtake. And for that offtake to be worth deploying needed capital, a proper valuation for avoided emissions upstream of the biogas plant is needed, which requires the right life cycle calculation. Fortunately, we have many excellent low-carbon fuel standard calculation methods to build from. Canada's carbon CFR is now using a very straightforward method for quantifying landfill diversion, and the default manure credit used in Europe seems broadly applicable and fair. The devil is in the details, but I hope these briefings encourage real conversation, and that's a conversation I'd love to have with you. Please visit my website, rngconnect.com, for supporting documentation and to contact me. And please follow along for more briefings and analysis. Thank you very much.